Hello, and welcome to Math 8, Unit 2A, Lesson 6. Today's objective is scholars will compare functions written in different representations. We've talked about functions, we've talked about different ways they can be represented, and now we're going to compare them. So, how can functions be represented? So, let's look at this story. 3 cars are traveling to the same campground along the same route. The cars began at the same place, but at different times. Car A began the trip at noon, and cars B and C began the trip at different times before noon. The miles traveled by cars A, B, and C are represented respectively by the following graph, table, and equation. That means that car A is represented by a graph, car B by a table, and car C by an equation. So, let's take a look at this. You can see here we have the distance that car A traveled, the distance that car B travels, and then car C is D equals 68t plus 20, where D represents the total distance, and T represents the time after noon in hours. So, that's the information we have, and now we're being asked a question. At what time, if ever, will car A pass each of the other cars? Describe any assumptions you made to justify your answer. So we're going to decide, will car A ever pass? At what time will car A pass each of the other cars? Okay, so we have here car A. Here's car B. And here is car C. Okay, so let's look at how we can answer this. Okay, so our best bet is to go ahead and put this all into one formatted table. So let's look first at the graph that we have here for car A. It looks like car A is going about 75 miles each hour. So that means at 1 hour it's at 75. At 2, it's at 150. At 3, it's at 225. At 4, it's at 300. And at 5, it's at 375. Well, for car C, we're going to need to replace T with the time. In this case, we'll start out with the time of 1. So, we're going to do 68 times 1 plus 20, which gives us 88. Then we do the same thing with 2. 68 times 2 plus 20, which gives us 156. And we're going to keep going with replacing those with our t's. So the next number we get is 224. And then we get 292. And then we get 360. Nice and easy. Now we've filled in our table. So let's use this table. The question we were asked is, at what time, if ever, will car A pass each of the other cars? So let's look at this. We see that at 5 hours, car A has gone 375 miles, car B has gone 370, and car C has gone 360. That means at some point, car A has passed the other cars. So the first thing we're going to do is we're going to start by using a sentence starter. So I'll say car A will pass car C at, and then again, car A will pass car B at. Okay, so that's what we're doing first. So first, let's look at when will car A pass car C. If we look we can see that at 4 hours, car A has gone 300 miles. Car C has only gone 292. But at hour 3, they got 225. They got 224, so we passed it then. So we must have passed it just before the 3rd hour. Remember that these are hours since noon. So 3 hours after noon is a little before 3. At a little before 3 p.m. Now let's look at when we'll pass car B. So, again, we can see here that 375, 370, so we've obviously passed it. But we hadn't passed it here. It's past us hour 4. So it must be between 4 and 5 p.m. So I'm actually going to erase this. Does it at? I'm going to say between. Between 4 and 5 p.m. So the next question asks us to describe any assumptions you made. So the one assumption I made was that every car was traveling at a constant rate of speed. So I'm going to put that down here. I assumed, can't spell, I assumed that each car was traveling at a constant rate. And that's how you answer that. Okay, if you have any questions, I will see you in class.